Hello and welcome to today's lesson. In today's lesson, we'll be treating the addition of like and unlike fractions. At the end of this lesson, it is expected that you'll be able to add fractions, whether they are like or unlike fractions. Let's get started. So what are like fractions? Like fractions are fractions that have the same denominator, but they may have different numerators, but they have the same denominators. For example, the first two fractions here, the first one is 1/4 and the second one is 3/4. So they both have a denominator of 4. So these two fractions can be regarded as like fractions. The second set of examples, the first one is 1/2, also called half, and the second one is 3/2, which is also called 1/2. If you look at these two, this one is an improper fraction, but they both have the same denominators. So these kind of fractions, like fractions, the rules for adding like fraction, it's very straightforward and simple. We'll get to it shortly. What about unlike fractions? Unlike fractions are fractions with different denominators. They are unlike because they don't have the same denominators. In this example, we see 2/7 or 2/7, and the second fraction is 4/9 or 4/9. What we see here is that the denominator of the first fraction is 7, the denominator of the second fraction is 7, so we can call these two fractions unlike fractions. If you look at the second set of fractions, this is 3/20 and this is 4/10 or 4/10. We can look at their denominator and we see that for the first fraction has a denominator of 20 and the second fraction has a denominator of 10, and these two are not the same, so therefore they are unlike fractions. So why do I need to know about unlike fractions? Well, there's a simple reason. The reason is because when you are adding and you are subtracting like and unlike fractions, there are different rules. For example, in the addition of like fractions, the addition is straightforward. All you need to do is to select one of the denominators and write it as the new denominator. And what you do is to add up the numerators. So in this example, we have 1/3 plus 2/3. So we just select one of the denominators, which is 3, and we write it as our new denominator. And then we take the two numerators and add them together, 1 plus 2. And so we have 3/3, which is same as 1. So the addition of like terms is very straightforward. However, unlike terms are not like that. So let's get to it. So before we go on to add unlike terms, let's quickly look at a couple of examples for like fractions so that we get our understanding very strong and solid. Okay, so how do we add 4/9 to 7/9? The first thing is that you check the denominator and you see that they are like fractions. So the next step is to go ahead and add them. So what do we do? Well, it's pretty simple. All you need to do is to choose one of the denominators and make it your new denominator. So 4/9 plus 7/9 will be equal to, our new denominator is 9, so we choose just one of them, and then we go ahead and add up whatever is in the numerators. So we have 4 plus 7, so 4 plus 7. So if we add 4 to 7, that's going to be 11 divided by 9. So we can leave our answer as an improper fraction, which is 11/9, or we can go ahead and make it a mixed fraction. And how we make fraction is by dividing 11 by 9. So how many 9s can you find in 11? 1. So write down 1. Now if you deduct 9 from 11, how many do you have left? That's 2. So we're going to write whatever is left as our numerator, so that's 2, and our denominator is going to remain as 9. So this is how we write mixed fractions from improper fractions. Now you can also convert this mixed fraction back to an improper fraction. How do you do that? All you need to do is to multiply the whole number by the denominator. In this case, it's 9. So 9 times 1 gives 9. But that's not the end. So you also want to add the 2 that is the numerator. So you add whatever you obtain after multiplying the whole number by the denominator. You add to the numerator. So 9 plus 2 gives us 11. So you now write it out as 11 over 9, just like it is here. So that's how we can convert between improper fractions and mixed fractions, and mixed fraction and improper fractions. Let's go to the second example. In the second example, we are asked to add a set of algebraic fractions. We don't know what x is, but we know it's a number. But you don't really need to know what it is to solve this. So how do we solve this? The same rule applies. First, do they have the same denominator? Yes, they do. So we choose one of the denominators, which is x, and we add whatever we find at the top. So it's going to be 4 plus 3. So if we add it up, that's going to be 7 divided by x. So that's our new fraction. So for unlike fractions, there are actually two methods that we can employ. There is the first method is called the lowest common multiple method, or the LCM method, and we also have the equivalent fraction method. But first, let's look at the lowest common multiple method. So I'm sure you have been taught how to derive the lowest common multiple when you have two numbers. In this example, we have two numbers, two denominators, 8 and 4, and these two denominators are different. They are called, therefore these two fractions are unlike fractions. So when you're adding unlike fractions, one method that you can use is to find what's the lowest common multiple between these two fractions. So let's try and do that. There are different ways of finding lowest common multiple. I will teach one method in this lesson, and I will teach two other methods in subsequent lessons. So the first method is the method of using prime numbers. You know, prime numbers are numbers that are divided by 1 and by itself. So for example, 2 is a prime number. It can be divided by 1 and can also be divided by 2, which is itself. 3 is another prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number, and so on. So what you do is you break down each of these into their prime numbers. So 8 is going to be 4 times 2. But 4 is not a prime number, right? So we're going to break 4 into smaller terms so that we reach the prime number. So 4 is the same as 2 times 2. So now we have how many prime numbers? That is 1, that is 2, and that is 3. Now let's do the same for 4. So 4 is 2 times 2. So, and that's it, because we already reached the prime numbers. We can't go any further. Now what we now do is to select between these two numbers. So there is 2 here and there is 2 there. So we write down 1, 2. There is another 2 there, there's another 2 there, we write down multiplied by 2. So we are left with one prime number that has not been accounted for, so you take that as well. So 2. And then if you multiply this out, you have it as 8. So the lowest common multiple here is 8. So we're going to write that value of the lowest common multiple as our new denominator. So we're going to write 8 as our new denominator. Now you don't just go ahead and add it up, add 7 plus 3 just like we did in like fractions. You're going to make a mistake that way. So that's not the way to go. So the next thing you want to do is that you look at the denominator of the first one. It is 8. So if you divide 8, which is our new denominator, by by the fractions denominator, which is 8. That's why I put them in different colors so that you can see. The 8 here goes here one time. So once you have that value, the next thing you do is you multiply this 1 by the numerator. So 1 times 7 gives 7. So you write 7 here, and then you write the addition sign. This addition sign, you bring it down there. Then the next one is, the next denominator is 4. So we're going to divide 8 divided by 4. So how many times does 4 go in 8? That's 2 times. So that's going to be equal to 2. Okay, so we're going to multiply these 2 by the numerator here, which is 3. So 3 times 2 is 6. Okay, so the next thing is you want to solve this. 7 plus 6 is 13 divided by 8. So you can write this in a mixed fraction form. So 8, how many times how many 8s can we find in 13? So 8 in 13 is 1. So we write 1 down. So what is the leftover? So 13 minus 8 is 5. So that's 5. And then what is the denominator? It's 8. So our new fraction is 1/5/8. So in this second method, which is called the equivalent fraction method, you are going to arrive at the same answer, but we're going to arrive differently. So how do we go about this? Well, the whole principle behind the equivalent fraction method is that you want to turn one fraction to have the same denominator like the other one. In other words, we want to convert these two fractions into like fractions. So the aim is you want to convert these two fractions to become like fractions. And we say fractions are like fractions when they have the same denominator. So the aim is that you want to make the denominator to be the same. So we have two denominators here. There is an 8 and there's a 4. So what we want to do is that we want to make sure that the smaller denominator, which is 4, becomes 8. So what can we multiply with 4 that will give us 8? What can we multiply 4 by that will give us 8? So 4 multiplied by 2 gives us 8. So what we do now is to multiply this whole fraction, both the numerator and the denominator, by 2 each. And then we'll have a fraction called an equivalent fraction. And the reason it's that way is because even though we are multiplying by 2, we are not changing the value of the fraction. It's still going to be 3/4. What do we mean? 3/4 multiplied by 2/2. Now 2/2, if you divide 2 by 2, what do you obtain? 1. So we are essentially multiplying this fraction by 1. So we are not changing its value. It's still the same value. But we're going to turn it to an equivalent fraction that has different numerator and different denominator. So 3 times 2 is going to give us what? 6. And 4 times 2 is going to give us 8. So that's our equivalent fraction. So 6/8 is the same as 3/4. Now we're going to bring 7/8 down. And now we're going to add it like fractions. Straightforward, isn't it? So now we write 8 as our new denominator since they have the same denominator. And then we add 7 plus 6. So 7 plus 6. So, and then this is going to be 7 plus 6 is going to be 13 divided by 8. And 13 divided by 8 can be written in a mixed fraction form, 1/5/8. So in conclusion, when you are adding fractions, like fractions is very straightforward. You select one of the denominators and you add the numerators together. Unlike fractions, you can use two methods. There's an LCM method, which you find the LCM between the two numbers and you solve accordingly. And there's an equivalent fraction method in which you turn the fractions into like fractions and then you add them up just like fractions. That's it on addition of like and unlike fractions. Thank you for watching.